Hello everyone, welcome back to Let's Unbound. We are now on FRQ 4 from the AP Calculus AB 2025 exam. And yes, this one is part of the non-calculator section. This question covers several must-know concepts and smart strategies. So make sure to watch the video from the beginning till the end. Grab your pen and paper and solve along with me. And one more thing, if you have any questions or if you find a different approach or want to share your thoughts, feel free to drop a comment below. And if you find this video helpful, we would love to hear your feedback. So let's dive into FRQ4 and get started. No calculated. Okay, it's a graphical analysis and accumulated function question. So this is also a repetitive pattern of question that we can find in AP Calculus AB. So the continuous function f is defined on the closed interval is given. So it's continuous. And it is defined from -6 to 12, the graph of f consisting of two semicircles and one line segment. So this is given. Let g be the function defined by. So based on your f, another function g is defined, and this is what it is. It is an accumulated function. G of x is 6 to x f of t dt. So x is based on whichever we are working. If you work from 6 to 12, it will be a line segment function. Correct? Right. So now we have 4 sub-questions as usual. Find g prime 8. Give reason for your answer. Find all values of x in open interval at which the graph of g has a point of inflection. Find g of 12 and g of 0. Label your answers. Find the value of x at which g attains an absolute minimum on the closed interval. Justify your answer. Okay. So let me break it down for you. First part A. So we have is about finding g prime 8. G be the function. Okay, g function is defined. Now I need to find g prime of 8. So you need to find what is g prime of x, right? So let's start with our g of x, which is given. G of x is integral 6 to x f of t dt. Okay, if you differentiate on both sides, g of x will become g prime of x. That's what I need. What happened to the right side function? If you differentiate an integral, differentiation integral or inverse processes, right? So they will just cancel and you won't get f of t, you will get f of x. Okay, whatever the variable in the accumulated function, so that it will take. So this is a property we know. So g prime of x is f of x. Now we need to find g of 8, g prime of 8. So just plug in 8. G prime of 8 is nothing but f of 8. Can I find f of 8? Yes, the graph of f is given clearly. So when x is 8, what is your f? So it is on a line and this is the point. It is 1. Correct? So 8, 1. F of 8 is 1. So your g prime of 8 is just 1. Got it? Very simple first part. Now, we are moving to part B. Find all the values of x in the open interval -6 to 12 at which the graph of g has a point of inflection. We are not aware about how the graph g looks like. But in this question, we have to find where g has a point of inflection and give reason for your answer. Let's start. All we know about g is, okay, a point of inflection means if g has a point of inflection, we need g prime needs a sign change. G double prime. Okay, so the concavity changes, there occurs the inflection. Concave up to down or concave down to up. So in this case, inflection point will occur. This we know. Okay, I need g double prime to make a conclusion here. So all I know is g prime we just now found. Okay, g of x we know it's an accumulation of f of t from 6 to x. G prime means what? Just now we did it in previous problem. G prime of x is f of x. Okay, what is g double prime of x? It is f prime x. Okay, now this is very important thing. I'm going to tell about inflection point of g with the help of f. Got it? Okay. So now this is here we need to be very clear, and this is an important point. So focus here. I need g has point of inflection. So we will g have to change the shape. Okay. If G have to change the shapes, then G double prime change its sign. At some point, it will change the sign. So that one. Okay, but I need to convert into F part, right? G double dash is nothing but F. So G double dash is F prime. So instead G double prime, I can say F prime change sign. Now, okay, this is what it is equivalent to. Okay, still F prime, I don't have any clue about F prime. All I have is graph of F. So now F prime changed the sign. So how can I relate it with the graph of F? So F will change either increasing behavior to decreasing, or it will go decreasing to increase behavior. If you find these cases in your F graph, then G has a point of inflection. So we are connecting G and F in this way. Okay, so all this or interpretation I'm telling you, I'm just breaking it down this much for you because just to explain the core concept here. Okay, so if G has a point of inflection, F should change from increasing behavior to decreasing behavior or vice versa. Right? Okay, now let's analyze the graph. Here we go. This is where you can see that increasing to decreasing. So this is decreasing, decreasing, decreasing. And suddenly after this, it's increasing. What is that point? Through observation, we can get it's -3. And increasing, again, it's increasing. Correct? So don't confuse with this. It's increasing and it changes the shape and increasing. So this 0 is not considered. And after this point, it's getting decreasing. It's getting left to right, it's going down. That is decreasing. So 3. Then after this, decreasing to increasing manner. So at 6 also it increases. So these are the F changes its behavior at x is equal to changes increasing, decreasing behavior at x is equal to -3, +3, and 6. This means G has point of inflection at these points. So G has POI means point of inflection at x is -3, 3, and 6. This is a very important strategy and a technique that you should know here. Okay, how we relate G and F. All you have F graph, so we completely depend on this. So that's the thing. I hope this is clear to you. Now, we are moving to part C. Find G of 12 and G of 0. Label your answer. Okay, right. Here we go. G of x is clearly given to us. This is G of x is accumulation of f. Accumulation of your graph f. Okay, this is just a variable and 6 to x. I need G of 12. Okay, so G of 12 is 6 to, in x you can put 12. That's what we are doing, f of t dt. So what does it mean? From +6 to 12 area under the graph. That is what this integral expression is telling us. It's a clear straight line. And if you make an area under a curve, it's a perfect right triangle, isn't it? So we can use half times base times height. Okay, what is my base? 6 to 12, it's 6 units. What is my height? 3 blocks, 3 units. So 18 by 2, it's 9. So G of 12 is 9. G of 12 is 9. Got it? Now, next part is G of x. G of 0. So G of 0 is integral 6 to 0 f of t dt. Okay, usually the integral should have a to b means the limits, it's a less than b. But here this lower limit is greater than. So what you can do is, let's apply this property. Give a minus before it and you can interchange the limits 0 to 6 f of t dt. So from 0 to 6, what is the area under the curve? Under the means it doesn't mean it should be the graph is under. So this area we are looking for G of 0 and with a negative. Okay, so 0 to 6 area under the curve, the semicircle. And what is the radius of the circle here? 3 units. It's the radius, correct? So this is nothing but negative 1 by 2 pi r square. R is 3 here, so 3 square. And that's it, negative 9 pi by 2. It's not positive 9 pi by 2. So be more cautious. Okay, do the steps properly. Otherwise, even if you follow all this and you forget to manipulate this sign, so you will get it wrong, right? So g of 0 is negative 9 pi by 2, right? And that's the thing. Here we go for part D. Find the value of x at which g attains an absolute minimum. Okay, the g function attains an absolute minimum at which at what values of x on this particular closed interval. Justify your answer. Okay, so absolute minimum means you have to check the endpoints, and also if any relative minimum in between that we need to check. Okay, how will we do relative minimum? When the relative minimum occurs, relative minimum, because absolute minimum is very simple, we can do that at the time of candidate test. So relative minimum occurs when g prime, okay, I'm looking for relative minimum of g, so g prime changes its sign. So that is decreasing to increasing manner, something we need here, right? So if that is the relative, so this is also a sign change, positive to negative, but it's relative maximum. So you need a sign change, and also it's negative to positive manner, right? So let's see where it is negative to positive. G prime equal to F. Okay. So I need to go and check F where it's negative to positive changes there. I need to check it. So this is completely negative F because below x-axis, and this is increasing manner. After this, it's completely increasing. Correct? Only above x-axis. So when I mean negative to positive, I mean the y value. Okay. So negative means below x-axis. Positive means above x-axis. Right? So where it happens only at x is equal to 0. So my relative minimum is 0. Relative minimum occurs at 0. Relative minimum occurs at x is equal to 0. Okay. Now, we need to find absolute minimum. Relative minimum also we will count it. Okay. And the next is candidate test. Let's apply for the endpoints. So we need to find g of -6, g of 12, and g of 0. That is the candidate test. So to get the absolute minimum, apply the candidates test. Okay. If in case if you got two relative minimum, you have to include those two relative minimum in your candidate test. Okay. Right. So candidate test when x is -6, what is g of x? Because we are checking about relative minimum, absolute minimum for g. Okay, don't confuse with f and g. So g of x. And what is g of -6? I think we did solve it before. G of -6, no. G of 12 we solved. G of 0 we solved. Okay, so g of 6 we need to solve it. -6. Then g of 0 it's already solved and we got -9 pi by 2. And g of 12 we solved already. It is 9. Right? So 9. Okay, only thing I need to find is g of -6. Then easily, which is minimum, we can pick that value. That's all. Okay. So finding g of 6. So what is g of x? 6 to x f of t dt. And it is 6 to -6 f of t dt. Do the sign manipulation because it's area under the curve, right? I give a negative and they interchange the limits so that they will be in order. Okay, -6 to 6, you need to find the area. So this is -9 pi by 2. Because it's below x-axis, this is +9 pi by 2. And I'm putting minus -6 to, so we can just stand it up. 9 pi by 2, -9 pi by 2 plus 9 pi by 2, and it's completely 0 here. So actually here I should put g of -6. G of negative 6 will be 0. Got it? So G of negative 6 is 0. And now we can conclude this. What is our absolute minimum? So on all these, which is the minimum value? This negative, of course, right? So this is where absolute minimum occurs. So G at times absolute minimum at, okay, let me write it over here. G at times absolute minimum at x is equal to 0. Justify your answer. Of course, we did all the tests. So you can tell us there is a sign change. We included that 0. Okay, and also it is smaller than. As there's sign change. And not only that, it's also smaller than the endpoints. Also smaller than G of negative 6 and G of 12. So this justification completes the answer. Okay, instead giving raw stuff, you know all this list, that's why we are doing this a proper way of solving, but still final justify your answer, you can include this in your own words. And that's a wrap for FRQ4. So thank you so much for joining in this video. I hope this video might be helpful. If yes, so do share it with your friends and subscribe for other updates. So save this playlist so you can come back and revise anytime. And also we have many more AP Calculus videos on our Let's Unbound YouTube channel. Be sure to check them out. Yes, if you want to connect with other students and get updates, you can join our Let's Unbound student community WhatsApp group. You can just click the link given in the description below. Thank you for watching again. Keep learning, keep practicing. I will be back with next video very soon.